Hi guys, welcome to my channel. Today we're going to learn about AI. Artificial intelligence is basically a robot trying to be a human. They make decisions on their own and they can do things without a human telling them to. Generative AI specifically creates things off of data it already has. When you think of generative AI, the first thing that probably comes to your mind are chatbots. That is called natural language generation. You prompt a chatbot like ChatGPT with a prompt, and then it generates an answer for you. All of these generative models are traditionally built off of large language models or small language models. This also is the same concept for image generation and code generation. So now you're going to ask, how does a large language model work? Large language models use natural language processing, otherwise known as NLP. For example, when you are texting ChatGPT about your day, it doesn't actually understand what you're saying. It is taking each word and breaking it down and indexing it into numbers and vectors that it understands in its computer language. That is called tokenization, word embedding, and architectural development. So no, your AI girlfriend does not actually understand you, even though she will say that. So let's jump into an example of tokenization. This visual breaks down how the computer takes different words and categorizes them into a token, which is always a numeric value. As you can see in the visual, step 1, it's reading the sentence. Step 2, it is breaking it down word by word. 3, taking the main points. And then 4 is categorizing those. Next up, we have word embedding. So this is another very important key concept applied in deep learning techniques. So now the AI is looking at all of these words and seeing similarities between other sentences that it's seen before. So it's recognizing patterns. So if someone always says, "Hey, I love blank," it's going to say, okay, that word love, what usually comes after that in my vast data set of people saying I love something? AI is very, very good at recognizing patterns. You can think of it like a giant dictionary with a very smart detective weaving every clue and context together. Instead of it being crimes though, it's words. I just watched a spy movie, so I'm gonna have a lot of spy analogies today. But check out this sick graphic from Microsoft that goes into more detail about how tokens are broken down into the vector space and how they all get embedded with different numbers that categorize them. I'm not good at math at all, but I know a cosine when I see one. Haha. So notice how cat, puppy, and dog are all close to each other, but skateboard is far away because they really have nothing in common. As a robot myself, I mean a human, words are my arch nemesis. Architectural developments. Okay, I got it down. That is the design or architecture of a machine learning model, and it's how the data is structured and organized. Recurrent neural networks, or RNNs, are used to, we all know someone who cannot read the room, right? And they could use something like an RNN because what they do is they take things and put it into context. Because we all know the same sentence in a different tone of voice or situation can mean very different things. An RNN is really good at predicting the future, right? So if you look at this example, it says Vincent was a painter known for mask, which is kind of the same thing as missing in this case. But what an RNN does is it predicts, well, we know Vincent was a painter, so what was he known for? Art. Well, usually. I don't actually know. I'm kidding, I love Vincent van Gogh. Mona Lisa. Definitely try this prompt in ChatGPT, Copilot, or Gemini to see what it gives you. And then as you can see in this visual, that's a little more in depth about the flow process of how RNNs work. I got this from Microsoft's website. I love their little tutorials and walkthroughs. I have a lot of XP on there. Add me. Can you add people on Microsoft Learn? Now on to transformer architecture. Woo! There are two main components of transformer architecture that you need to know about. First is the encoder, and that is responsible for processing the input, which would be your sentence that you're asking or prompting the AI with, and then creating a representation that captures all of the tokens and how they're getting categorized. Next, you have the decoder, which generates the output of the sequence from the encoder. Now, we're going to talk about attention, which of course I love. No, but for the AI, attention is a mechanism used to map out new information. Think back to the detective with their board of all of the clues. Formers use the attention function. So when they see a new word, they turn it into a query, right? And then the output is encoded with a word that's associated with the value, usually from the vector. As you can see in this table, the key is Vincent van Gogh, and the values are that he's a painter. This is all held usually tabularly. Today at work, we were going over an Excel sheet, and there's something like, oh, the name of this definition, and then the description of it. Kind of think of it like that. So a key would be an apple, and the value would be like round and red and fruit. This magical math then goes to the vectors, and that's when the detective board comes back up again and all of the pieces are being put together. Super cool, super spooky. Next. So, we have large language models, which you hear about all the time in the AI hype news, but you also have small language models, and it's exactly what it sounds like. Sometimes these large language models have a lot going on, and it's way harder to train them, and there's way more things you need to do. However, if you use a small one, then you have fewer things to worry about when it comes to deploying, and it tends to be less buggy because you're working with less things. Next up, we have a very brief tutorial on how to prompt your AI to get the best answer. You have to be hyper-specific with your AI to ensure you get what you want. It's just like a conversation with someone at the grocery store. If you say, hey, where's the milk? They're gonna point at aisle 2. But in your head, you're like, well, no, can you show me exactly where the organic almond milk is? They don't know that, and neither does the AI unless you communicate that. If you need more information from Copilot, you can just keep asking it things. It's not like there's usually a limit on the chatbot, right? So if it's too broad at first, just keep drilling down. Next up, we have a pop quiz. Quick question for you guys. What are the two components of transformer architecture that are supporting today's generative AI? Is it recurrent neural networks and memory retention? Yes. Thank you for watching. Like, comment, subscribe, and share.